So today we are going to talk about another way to display a set of data, and it has similar characteristics to a box and whisker plot. It's called a histogram. So a histogram is very similar to a bar graph, except a bar graph is a way to categorize things like how many people said their favorite type of ice cream is chocolate versus vanilla versus strawberry, etc. Where a histogram is like a frequency table. So it doesn't categorize things, it breaks things down into different intervals. So a couple of the important things to kind of underline here. So it shows the frequency of data values in intervals of the same size. And so this is another way that we would interpret like a shape of distribution. So a histogram and a box and whisker plot both will determine if something is skewed or symmetric. All right, and so we can kind of see here just kind of two examples. So these are adult male heights and adult female heights in inches. And so how we would interpret this, so this is broken up into like intervals of 5, so 55 to 60, and so on and so forth. And then this is the frequency. So what these little bars mean is that, for example, if I look like here, this bar right here is probably between like 65 and 66. And so that means that however many people they collected data from, about maybe like 10, that's about how high this bar is, about 10 of them were between 65 and 66 inches. That's how we'll interpret those bars. Okay. So both of these shapes I would consider to be pretty symmetrical. That's where this kind of like bell-shaped curve comes in. So to kind of add on what we did yesterday with box and whisker. So here, whisker. Here are kind of three different types of distributions. And so we still got the same titles, skewed left, symmetric, and skewed right. What you kind of have to make sure you understand though about histograms, a lot of people will say that these are backwards because they'll see here, the majority of the data is on the right side. So that must mean we think that it's like skewed right because that's where most of the data is. And then kind of opposite here, we've got most of the data on the left. So a lot of people would want to say that is skewed left, but it's skewed right. So what you kind of want to think, I always think about what this would look like as a box and whisker plot. If most of the data is on the right here, that means if we were to draw a box and whisker plot, we'd have like 75% of our data on the right side because this is where the data is really heavy. The bars are higher here. So in terms of the box and whisker plot, 50 to 75% of your data would be on the right side. So this right here, these shorter bars would essentially be making the tail longer on the box and whisker. Not the tail, I guess. That's what it's called here. The whisker would be longer on the left side, and that's skewed left. So remember what that means is that you've got this lower value that's kind of pulling your mean lower than what it really should be. Okay, so same thing with like skewed right. If most of our data is on the left, if I think of that as like a box and whisker, we've got 75% of our data on the left side. So the longer whisker making it skewed right is going to be on the right. That means here we've got this bigger value that's making the mean bigger than most of the data. And so then if something is symmetrical, they're approximately the same kind. So you've got kind of like a higher bar, 2 in the middle, and then they go down on either side. Now again, it's very rare that something is going to be exactly symmetric, especially when you're organizing using a histogram. It's a little bit more likely with box and whisker. And so we're just looking kind of at approximations in terms of how we interpret that. Okay. All right, and so what we're going to do is just kind of practice first making a histogram and then just looking at one little application of it. All right, and so in this first example, everything, the work is already organized for us. So here are all of my intervals right here. And then this is the frequencies. Okay, so what this means right here is, so this shows the number of raffle tickets sold by students in our grade. And so what this means is that between 1 and 8 tickets were sold 5 times. Between 9 and 16 tickets were sold 9 times, and so on and so forth. So again, these intervals are all even. 1, 2, 3, 4, 5, 6, 7, 8. They all contain those 8 values. Okay. And so what we have to do now is put this on our histogram. Make it kind of like a bar chart, right? So you always need to make sure you label your axes just like you would on any graph. So the x-axis is always going to be what your intervals essentially represent. So this represents the number of tickets sold. And then your y-axis is almost always going to be your frequency. How many times did that happen? And so what you want to do is you want to look at those frequencies to determine what your intervals should be on your histogram. So I see, and this will always, you'll always want to start at 0. And so what I notice here is that my highest value is 25. So if I make this like 5, 10, 15, 20, 25, I have enough to fit on that graph. You want to use as much of your graph as possible, so I probably wouldn't want to do 10, 20, and then that would be 30, because then I'd have this whole space up here that wouldn't be used. So you always want to make your interval as kind of tall as possible, take up as much of the space as you can. So what I'm going to do now, I'm going to show you a couple of different ways that you can write the intervals down here. Now, I don't really care when you're making your own histogram how you decide to do that, but you need to make sure that you can kind of interpret the different variations, because honestly, kind of depending on where you see it, it just can be written a little bit differently. And so I want to make sure you get exposure to all kind of different variations of that. So I first of all have 1, 2, 3, 4, 5, 6, 7, and so I'm going to make sure, and you can kind of already see some tick marks down here. So 1, 2, 3, 4, 5, 6, 7. And you want to make sure that each bar has approximately the same width, so that you can see the straight shape of distribution. All right, so one way that you can write this, which is kind of how I would do since it's already given to us here, is you can write them just like this. 1 to 8, 9 to 16, so kind of write them out smaller like that. The other way that you can do this, so it's a little bit more confusing when they're given to you in this kind of interval, as opposed to just me giving you a histogram and interpreting it from there, is writing it like this. So I would start, so my frequency would be 0, but this would be like 1, and then I would write a 9 here. And then I would write 17, 25, 33, 41, 49, and then this last one would actually be 57. Okay, so the way that you interpret it, if it's written like this, is the left side of each bar. So when I make this, when I cover it up, the left side of each bar is always the starting point of the interval. So what this means is that 9 would be included in this second bar. this so the right side is always where the next interval starts. So I would still interpret this as 1 through 8. Okay, and then this would be 9 through 16. So again, the left number of your bar is where the interval starts, and then this is where the next interval starts, and so on and so forth. Okay, so I already wrote this in there, so I'm just going to leave it like this. So this first interval here would go up to 5. And then this next one would go up to 9, so just under the 10. I could probably go a little bit below that. And then this next one goes up to 16, so a little bit above that. And then this next one goes all the way up to 25. And then down to 20. And then down to 8. And then down to 7. So my histogram would look like this. Okay. So now when describing the shape, I would kind of interpret this as being symmetrical. Again, it's not exact, but our highest bars are in the middle, and then they go down from there. So it's definitely not significantly skewed either left or right, and you can kind of see that in your organization here too. The highest numbers are in the middle, and then they go down from there. So I would say the best way to describe this would be symmetric, which means the mean and the median will be fairly close to each other. All right, and so that kind of idea of the shape of distribution also kind of coincides with when you're choosing an appropriate measure to determine the data. So again, if you have a symmetric histogram, the mean and the median will both be a good measure of center because that means that they're close to each other. But if you have data that is skewed, so for example, this would be skewed left, right? Because we've got these values over here. If I were to think of that as a box and whisker, most of my data is on the right, so my left whisker would be longer. So that means that I've got a lower mean than normal. So the median is not necessarily in the center, right? Because it's going to be bigger than the mean. And vice versa if our data is skewed right. So this means that our mean is going to be more up here and our median is going to be more on the left. So you want to use the median still to describe the average data. Okay. All right, so now what we're going to do here in this next one is we need to create our own table. So this one says right here, police officer measures the speed of 30 motorists. So we've got 30 pieces of data. So now this says display the data in a histogram using 6 intervals beginning with 31 to 35. Okay, so this is important. So I know that I'm going to have 6 intervals, and I have to make sure that those intervals have the same number of values, right? So I go 31, 32, 33, 34, 35. So each interval should be in increments of 5. So if I start with 31 to 35, then my next one would be 36, 36, 37, 38, 39 to 40. Right? So there's a difference of 4 between each starting and the stopping point. So then this next one would be 41 to 45. And then 46 to 50. And then 51 to 55, and then 56 to 60. Okay. And so now what we're going to do is, and I'm going to just kind of show you one example, and then I'll just tell you what the rest is to keep this video a little bit shorter. So now what we're going to do is we're just going to go through and count, or honestly it might be even faster and a little bit more accurate if we just go through and like put each speed where it goes. So like 32 would be here, so I'll put a tick mark here. 53 would go down here. So you're organizing your data based on the interval that's in. So 56 would be there, 50 would be here, and so on and so forth. Okay. Now again, just to save a little bit of time, I'm just going to go through and organize this for you. So there was one value here, 3 here, 5 in this interval, 6 in this interval, 11 in this interval, and 4 in this interval. And it's never a bad idea when you're organizing, especially decent amount of data, to verify, just add them all together. We should get 30. So 1 plus 3 plus 4 is 30. Okay, we're good here. Okay. All right, so now we need to put this on our histogram. So this is going to be speeds in miles per hour. That's what my these numbers are going to mean down here, and then this is going to be the frequency. Okay. And so again, when I am trying to determine what I go by, it looks like my highest value is 11. And so if I go 1, 2, 3, 4, 5, 6, 7, 8. Good. So I've got enough. To just go up by 1. So that's going to be the best thing to do. That way we can use our entire graph. Okay, so that is going to represent 0 for the frequencies, but then remember I want to start with 31 for the speeds. And so then if my next interval starts at 36, I put that there. My next interval starts at 41. My next interval starts at 46. My next interval starts at 51. So that means if I had a next interval, it would start at 56. So again, remember, the left side is where the interval starts. The right side is where the next interval starts. So this is still 31 to 35, 36 to 40, so on and so forth. And this is another time too, if you just wanted to say 31 to 35, 36 to 40. That's okay too. I'm just kind of practicing it this way so you guys can get used to seeing it like this as well. All right, so my first interval, I only had one car going between 31 and 35 miles per hour. In the next interval, I had 3. We counted 3 cars going between 36 and 40. I counted 5 cars going between 41 and 45. Then I counted 6 going between 46 and 50. And then 11 going between, oh, I forgot that last. Because I wrote it over here. So this would be 61. And then my last interval, I had 4 cars. All right, so now in terms of the distribution of this, it looks like I've got, 2 out of the 3 highest are on the right side, right? So if I think about it, if I have 6 bars, these are 2 of my highest ones. So that means that this is going to be skewed left. I'll put that kind of down here. This is going to be skewed left, right? Most of the data is on the right. So if I picture that box and whisker, these are making that left whisker a little bit longer. And so that means the median is going to be the best representation. Now, one of the things too I want to practice is identifying which interval. So if I ask you what interval would the median value be in? Okay. So I've got 30 values right here. The last thing I want to do is list out 30 values from least to greatest. So we need to be able to understand kind of like conceptually where that median would be. So if I just kind of can picture in my head, all right, I've got between 1 and 30. 1 and 30 values right here. Well, I know that if I divide 30 in half, I get 15. right? So that means wherever my median is, my median value is going to be the average of the 15th and 16th term, whatever that may be. Right, because I'm going to have, since I have an even amount of data, I'm going to have the 15th and the 16th, that would be in the middle. So in terms of figuring out where that would be, then this is where we use our frequencies to figure that out. So I need to figure out, okay, which interval would my 15th and 16th term be in if I listed all of those out? And that would tell me the interval that I'd fall in. So here, this would be 4 data pieces, this would be 9 data pieces, this would get me up to 15, and then, so that means my 16th value would be in here. And so if I'm thinking about what that means, essentially, that means this value would be the average of the whatever closest to these two would be. So this probably isn't the best example I would give you, one where it was actually in an interval. But it would be the average of, let's see, was there a car going 50? Was there a car going 50? There's one right here. Another one right here. Was there a car going 51? Another one right here. Was there a car going 51? So that means that the median would be, essentially exactly right there, kind of on the edge of these two bars. Okay, so be 51. So the median wouldn't actually be in a specific interval. It would be right on that kind of meeting ground between the two. Okay. And so the last question then is, the speed limit is 45 miles per hour. How would we interpret those results? Well, 45 miles per hour is the end of this interval, right? And so that means that most of the cars are speeding. Guilty. All right, so last example here is just kind of an application interpreting a histogram. So we've got these two histograms right here, double histogram chart. It says it shows the distribution of emoticon messages sent by a group of female students versus a group of male students over 1 week. Compare the distributions in the appropriate measures of center and distribution. All right, so we've got male students and female students. It looks like up here, my female students, my frequencies go up to 16. The males only go up to 14. So I'm not sure why they did that, because nothing's over 14 right here either. And then my frequencies are 0 to 9, 10 to 19, 20 to 29, and so on and so forth. All right, so in terms of the shapes, right, I would definitely say that the female students is pretty symmetric. We've got our two higher bars in the middle, and then we kind of go out on the sides. So I would say that the females are symmetric. Whereas the males, most of the data here is on the left side. So not as many emoticon messages are used with male students. So if most of the data is on the left, remember that means that our right whisker would be longer. Our box and whisker chart would be pretty compact over here with a longer whisker on the right. So we would say this is skewed right. And so in terms of the appropriate measures of center, if this is symmetric, then that means the mean and the median would be close. Whereas if it's skewed right, that means we're going to want to use the median because the mean is going to be lower. So my median would probably be in that bar. Not that bar. It would probably be like in this bar. So like if I told you that, let's say, well, we can actually figure that out. So there's 14, maybe this will be a better example of finding the bar. 14 plus 12 plus 6 plus 2 is what? So that would be 26 is what? So that's 34. 26. So if there are 34 messages that were looked at from the male students, so 34 divided by 2 is 17. So if that means that I'd have 17 values on either side. So the median is going to be the average of the 17th and the 18th message, or the 18th frequency. So yeah, this is a much better example. So 14 data values are in here, and 12 are in here. These two bars together contain 26 out of the 34 pieces of data. So our median, we don't know exactly what that value is, but we know that the median would be in this bar, because the 18th and the 17th value are in that bar. All right, and so that is it for histograms. On next Tuesday, we will look at more like categorical ways to organize data. So looking more at like bar graphs, pie charts, things like that. And you can't really tell shapes of distribution from those. So that's why these two lessons kind of work together. So your homework tonight is posted on Canvas. It's a 9.2 day 2 worksheet. And then just as always, hop onto the day 2 worksheet. And then just say, have a great day, guys.